for testing and debugging logic apps, more specifically workflows. The trigger history and runs history are your friends. You can find both via the overview blade. You've got a runs history and trigger history here, but I personally tend to use the runs history blade via the menu item more. We already looked into this a bit. Let's click one again. You can look at the flow of data through your logic app. You can click each part of the logic app and look at the inputs, the outputs, which gives you almost everything you need to try and figure out what's going wrong. Via Run Details, you can get an overview of all the specific details of this specific logic app run. You can see that the action send an email has succeeded. You can click through to it and you can get a link to the inputs. This gives you the inputs as one easy link. You can go back, get a link to the outputs as well, and you can do the same for each part of your logic app run. This should give you everything you need to debug logic app runs. As I also mentioned, when you resubmit a logic app run, the same input or the thing that triggered the logic app is reused, but the workflow that is executed is actually the most recent one. So like that, you can easily verify that a potential bug fix you made effectively works or not. When you right-click an action, you can also resubmit from a specific action. This is especially useful in workflows that are a bit more complicated than the one we have on screen here, where you may have 4, 5, 10 different actions that execute in this case or in that case. And you may see that your workflow works till about halfway through. Well, then you don't have to resubmit the full workflow. You can just start over from one specific action. Finally, the logic app, just as most Azure resources, has a metrics blade which you can use to get an at-a-glance overview of the health of your logic app, just like you can for most other Azure resources. Alright, let's up our game and integrate with an Azure function next. So, our demo scenario was monitoring blob storage for destination image changes, using that as a trigger to send an email to, for example, the team that needs to monitor those changes so they can do something with that. And then we were adding an additional thing, being an automated process to process those image changes. And that's what we're doing now. We're going to mimic that process as an Azure function. So for our demo, that means that's custom code we want to execute. There's an action you can actually use to execute custom code, and that is the inline code action. There's one for C#, and there's one for JavaScript as well. But more often than not, you already have the behavior you want to execute somewhere else, or you want to keep it separated from the logic app and make it more easy to reuse. The code could, for example, already be contained within an Azure function. So that is what I'm going to do. I'm going to integrate with an Azure function to mimic generating the reports. Now I could go ahead and create yet another function for that, but we already have functions laying around from the previous demos. I'm simply going to reuse one. The importance of this demo is not what happens inside of the function I'm going to execute. It's about showing you how to integrate with a function from a logic app, as that is a pretty common scenario. And I'm going to start with what looks logical, but won't actually work out of the box. At least not at the moment of recording, but I do want to show you this because I'm assuming that most of us will want to start like this. That is using the Azure function action. So I'm going to add an Azure function action here to be executed in parallel with sending that mail. So I simply look for Azure function, click it, and that brings us to the action. It's smart enough to find my Azure functions here. I'm going to select the travel inspiration function app, and let's select a function on it, say getting the itineraries. All right, let's click add action. So far so good. Here is our second action. Now let's click save. And this seems to fail. It states here that the endpoint cannot be called from a logic app because it uses a custom route. Well, that's kind of annoying, because I would assume that most functions would effectively use custom routes, unless you want the routes to your API endpoints, unless you want the routes to your function endpoints to end with the function name. That's typically not a good design. Now, it would be kind of weird if we wouldn't be able to do that somehow, right? And that is indeed true. If we have a look at the URL on Microsoft's documentation site and look for custom routes, we essentially read that we will need an OpenAPI definition for our function to be able to use these custom routes. So let's add one. Let me open my code base. We're in our travel inspiration functions. Let's open the NuGet dialog. And I want to search for Microsoft.azure.functions.worker.extensions.openapi. Be careful, make sure you choose this one. There's another package, Microsoft.azure.webjobs.extensions.openapi.core, that enables OpenAPI support for functions, but that one is for use in the deprecated in-process model. It will not work in the isolated worker model mode, which is what we are using. Anyway, let's install this one. This is the correct one. And there we go. Now let's set this up. I'm going to start by adding a bit of general information about our API that should end up in the Swagger or OpenAPI definition file. For that, I call into services.add_singleton, passing through OpenAPI configuration options. Essentially, like that, the code that ensures that the Swagger definition can be generated will pick up these options and read from them to create the Swagger definition file. What we want to create here and return is something of type OpenAPI configuration options. That's defined in the workspace you see on screen now, so let's import that and let's set some info on it. So I just want to set some general info, like the title, say travel inspiration, function app endpoints, maybe a description, all travel inspiration API endpoints that have been migrated to a function app. Why not? And if you wish, you can input contact information, license information, version information, and so on. I'm going to leave it at this. All right. That's it for some generic information. What we can do next is use annotations to decorate our functions, in which we can detail what the OpenAPI definition for those should look like. So I'm going to go for the get itineraries function. That's the one we're working with. So let me start with that one. Let's start by defining the OpenAPI operation. Let's give this operation a name. This should be a unique identifier in the OpenAPI definition. Get itineraries. Sounds good. And I'm also going to pass through get itineraries as a tag. And as a description, I'm going to say that this operation is meant to get the itineraries. With OpenAPI parameter, I can pass through information about the parameters for this function. We have one parameter, search for, as you can see on line 31 here. So let's describe that. I pass through the parameter name. The parameter location is in. It's an input parameter coming from the query string. It's not required. It's of type string. And let's set the description as well. Search for itineraries by part of their name or description. Lastly, I also want to define the response. So that shows up correct in the OpenAPI definition as well. As you may notice, I kind of think it's important to be specific in your OpenAPI definitions. After all, it's these things that people or systems that need to integrate with your functions will see first. So the more precise it is, the less help desk calls you will receive. To define the response, we use OpenAPI response with body because we effectively get back a response body. The status code for this one is okay. You can also define that for other status codes if you wish. That is a good idea, but, well, this is going to take ages and we need to stop somewhere. The type, the media type is application JSON. And the actual type that is in the response body is a list of itinerary DTO. All right, and like that, I've already nicely described this function, right? This is how it will end up in the OpenAPI definition. Let's save this already. And I'm quickly going to add likewise attributes for that other function, the non-durable one we have, that is create most viewed itineraries function. I'm not going to bore you with typing all of this out. We just went through this. This time I'm going to copy paste this in. There's nothing new here. All right. Let's run this locally and have a look. We see a few new function endpoints now. For example, one for the Swagger endpoint and one for Swagger UI. Let's click that one. And here's our Swagger UI. This gets its information from the Swagger definition here. And this Swagger definition is what we manipulated with the general info object and with the annotations. You can find the general info on top here. That's the description. And you can find what we inputted via the annotations at level of each function description. All right, so far for that. Now let's publish this, because we will need this online, of course. All right, publishing has succeeded. I'm going to discard my unsaved changes for now, so we can go and have a look at the function app. And indeed, here's our new endpoints, including Swagger UI endpoint. And indeed, down here we find our new function endpoints. Let's go back to our logic app. Let's open the designer again. We know what to do. We want to add a parallel branch with an Azure function action. We find the new endpoint. So far, so good. And I choose the get itineraries function. Choose to add an action. And let's save this. And it still fails. This, at the moment of recording, is a bug, I'm afraid. The good thing is we now have an OpenAPI definition for our function. That'll come in handy in one of the next sections. And this does allow me to show you that, as I mentioned before, in Azure, most things can be handled in different ways. So how can we integrate with our function then? Well, we've got an HTTP triggered function, right? So we can simply use an action that will send an HTTP request to that function. Let's do that instead. So I'm going to delete this. And I'm going to add a parallel branch. And I'm going to look for an HTTP trigger. That's the HTTP action I want. Let me choose that one. So I need to input the URL. Let's get that. I'm back at my function app. Let's go to the get itineraries function. Let's get the function URL with function key. Let me copy that. Let me paste it in here. The method is get, and I don't want to add headers or query string values here now. All right. Let's save this. Okay. And let's resubmit one of the previous runs to test this. So I'll resubmit. That was successfully done. Let's refresh. It seems that everything succeeded. And indeed, let's have a look at HTTP, what we got. So the request was sent, including the function code, which means we are authenticated. And as output, we indeed got back the expected output from getting the itineraries. That's not that important, of course. The important thing here is that we integrated with an Azure function. This works, but it isn't exactly the best approach, right? We have got this authentication info here, the function key, stored in our logic app, stored also in every logic app run. I'm not a big fan of that. As we know, a better way is to use a managed identity. Let's look into that next.